All right, welcome to our journey through the history of databases. Today, we're talking about a piece of technology that you might not know it, but it quietly powers so much of our digital lives. It's called FAIS. This is the library that really changed the game for how we search for things, making that incredible leap from just matching words to understanding complex meaning. Its story, well, it's a huge chapter in how data and intelligence have evolved. So, to really get this, we have to start with a question that sounds simple but is actually pretty deep. When you go searching for something, you're not always looking for an exact word, right? You're looking for a concept, an idea, a vibe. But how in the world do you teach a machine, a computer, what similar actually means? That is the core problem we're talking about. And you know what? This challenge actually has a name, the similarity search problem. Before tools like FAIS showed up, trying to find things that were conceptually similar, like think images or songs or documents, inside these massive data sets was just painfully slow and incredibly hard. You were basically stuck just searching for keywords, not the actual meaning behind them. And the difference is, well, it's night and day. Over on the left, you've got your traditional keyword search. It's super literal. You type in fast car, and you get back pages that have those exact two words. But then, look at the right. That's similarity search. A search for fast car gets the idea. It brings back pictures of sports cars, articles about racing, even if the exact words fast car are nowhere to be found. See the difference? So, how did we make that jump, from simple, dumb keywords to this complex understanding of meaning? Well, a huge piece of the puzzle came from Meta AI. They came up with a solution, a library called FAIS. And it didn't just make search a little better, it made this whole new kind of search, what we call vector search, actually practical to use on a massive, massive scale for the very first time. So what is this thing exactly? FAIS, which, by the way, stands for Facebook AI Similarity Search, was released way back in 2017. At its heart, it's a super specialized library that is designed to do one thing and do it exceptionally well. Find the most similar items inside a huge collection of what are called dense vectors. And you can just think of vectors as basically numerical fingerprints for any piece of data. And it came out of the gate with some absolutely killer features that made everyone want to use it. For starters, it was open source, which was huge. Anyone could use it. It was also highly optimized to run on regular CPUs and, this is the important part, on GPUs, which made it just blazing fast. On top of that, it could handle billions with a B of vectors. And hey, it was already battle tested inside Facebook. A pretty good resume, right? Okay, that all sounds great, but how does it actually work, right? How does FAIS manage to dig through billions of things and find the perfect match in just milliseconds? The whole process is actually pretty fascinating, so let's break it down. Now, here is the absolute most important thing to get. FAS doesn't know anything about your original pictures or your text documents. It doesn't care. It only works with their numerical representations, which we call embeddings or vectors. So first, an AI model will read your data, and then it turns its meaning into a long list of numbers. And that list of numbers, that's the embedding. And here's what that whole workflow looks like. You start with your raw data, text, images, whatever. That gets fed into an embedding model, which, like we said, turns it all into numerical vectors. Then, Feist takes all those vectors and organizes them into this super efficient structure called an index. And finally, when you search for something new, that search query also gets turned into a vector, and Feist just finds its nearest neighbors inside that index. Simple as that. Now, what's really cool is that FAIS isn't a one-size-fits-all kind of thing. It actually gives you different ways to index your data, all based on what you need. If you need perfect 100% accuracy, sure, you could use a brute force search, but it's going to be slow. In the real world, developers use much smarter methods, like IVF or HSNW, where you trade like a tiny, tiny fraction of accuracy for these enormous gains in speed. It's a trade-off, and it's almost always worth it. And this is where it all comes together. That ability to be incredibly fast, but at a massive scale. That is what completely changed the game. This wasn't just some small improvement. No, this was a breakthrough that unlocked entirely new kinds of applications that just weren't possible before. And when we say scale, we really mean it. FAIS was built from the ground up to handle collections of over 1 billion items. That's 1 billion images, 1 billion documents, 1 billion products, and it can find the perfect match in the blink of an eye. Just wrap your head around that number for a second. I mean, just look at this comparison. The difference in performance is absolutely staggering. A search that might take a brute force method hours or maybe even days to complete, FAIS can do in a fraction of a second. That kind of speed isn't just an improvement, it's what makes so many of the apps we use every day even possible in the first place. So, where do you actually see this stuff in action? Oh, it's everywhere. It's the magic behind the recommendation engines that tell you what to watch next. It powers reverse image search and facial recognition. And maybe most importantly today, it's a critical piece of the puzzle for giving large language models a long-term memory. In fact, things like retrieval augmented generation, or RAG, which powers so many AI assistants today, they'd be impractically slow without the foundational speed that FAIS provides. So if you zoom all the way out, it becomes really clear that FAIS isn't just another library. In the grand history of databases and search technology, it represents a truly pivotal moment. It laid down all the practical groundwork for the entire category of modern vector databases that we see exploding in popularity today. There's this quote that I think just nails it. It's not just fast, it's fundamental. The speed was what got all the headlines, of course, but its real, lasting impact was that it made vector search a fundamental, accessible building block that any developer anywhere could use. It basically democratized the ability to search by meaning. And this timeline just puts it all into perfect context. Before 2017, vector search was, well, it was mostly an academic thing, a niche concept. Then 2017 happens. Meta AI open sources FAIS. And that single event kicked off the entire modern era, leading directly to the powerful vector databases and AI apps we have today. It was the spark that lit the fire. So we're left with this final thought. FAIS solved the problem of speed at scale, which was a monumental achievement in the history of search, no question. But as we look ahead, the next big challenge isn't just about speed anymore. The question we have to ask now is, what comes next? What's the thing that's going to make our search systems not just faster, but truly smarter?